Welcome back. Today we'll be talking about the triple integral. We've talked about double integrals before, but the triple integral we can also do. We integrate 3 times, and it helps us to find volumes and also helps us to integrate over 3-dimensional regions. So triple integrals are defined using a triple Riemann sum, which we won't go through here because it'll be very long and complicated. But let's look at an example of how to compute a triple integral. Suppose we want to compute the triple integral of this function, x squared y e to the xyz, over this 3-dimensional box where x goes from 0 to 1, y goes from 1 to 2, and z goes from 2 to 3. How would we do this? Well, we'd write it like this, the triple integral over this box, this 3-dimensional region of the function dv. And so we'd write it just as 3 integrals right after each other. And this dz, dy, dx is telling us we're integrating with respect to z first, then with respect to y, then with respect to x. So first we integrate with respect to z, and so our first bounds, 2 and 3, which come from here, are our bounds from z. Then our bounds for y, which we're integrating with respect to next, are 1 and 2. So we see a 1 and 2 for our next bounds. And then finally we're integrating with respect to x, and the bounds on x are 0 to 1. So our bounds are 0 and 1. So how do we evaluate this integral? Well, we just take the integral of this whatever's inside with respect to z with these bounds. Then we take the integral with after we get our result, we take the integral with respect to y with these bounds. And then finally, with whatever result we get, we take the integral with respect to x with these bounds. So the first step is the integral with respect to z of whatever's inside. If we take the integral of this with respect to z, it's e to a constant times z. So that gives us e to the xyz, but then we have to multiply by 1 over xy. So if we take this whole thing and multiply by 1 over xy, we get this. So this is the integral with respect to z of x squared y e to the xyz. And we want to evaluate that from 2 to 3, since those were our bounds. So what happens when we evaluate it from 2 to 3? If we plug in 3 for z, we get x e to the 3xy. And if we plug in 2 for z, we get x e to the 2xy. So we're subtracting those two. So we just evaluated our first integral. Now we move on to the next one. We integrate with respect to y in this triple integral. So how do we integrate this whole thing with respect to y? The first term integrated with respect to y, we need to divide the whole thing by 3x, but the e to the 3xy stays the same. So if we divide by 3x, we get 1/3 e to the 3xy. And same thing over here, we divide by the constant in front of the y and then leave the e to the 2xy. So dividing this by 2x gives us 1/2 e to the 2xy. And then we're evaluating that from 1 to 2, which are the bounds for y. What happens when we do that? If we plug in 2 for y and then 1 for y and subtract them, we get this expression right here, which is a long expression, but we're almost done. So now we need to integrate this whole expression right here, with respect to x. What happens when we do that? Integrating e to the 6x times 1/3 gives us 1/6 times this whole thing, so 1/18 e to the 6x. Then for this e to the 4x, we multiply by a 1/4, so we get 1/8 e to the 4x. Integral of 1/3 e to the 3x is 1/9 e to the 3x. And then integral of 1/2 e to the 2x is 1/4 e to the 2x. And then finally, we're evaluating that from 0 to 1. So if we plug in 1 for x, we get 1/18 e to the 6th minus 1/8 e to the 4th minus 1/9 e cubed plus 1/4 e squared. And if we plug in 0 for x, all the e to the powers become 1. So we get 1/18 minus 1/8 minus 1/9 plus 1/4. So this is our final answer for this triple integral. And that's how we evaluate a triple integral, even if it gives us a complicated answer.